We'll be going over the Unit 5 test review today for pre-calculus. The things that you may find useful for the Unit 5 test review, as well as for the Unit 5 test, are a unit circle, where you can find the cosine, sine, and tangent of these different values. And you'll also want to have your trigonometric identities, primarily your reciprocal identities, your quotient identities, and your Pythagorean identities. So I'm going to have these two off to the side, and I'll be referencing them from time to time. All right, let's begin. Number 1, given the following values, evaluate, if possible, all other trigonometric functions. So I've got sine of theta equals 0 and cosine of theta equals 1. So what I like to do with these, given sine, cosine, cosecant, or secant, I like to write these as kind of a fraction. So I would write 0 as simply 0 over 1, and cosine as 1 over 1. And the reason for this is that sine and cosecant, these are reciprocals of each other. Meaning, if this is 0 over 1, then when I go to flip this upside down, cosecant would be 1 over 0. However, 1 over 0, I can't ever have a denominator of 0. I can't ever divide by 0. So I would say that the cosecant of theta is undetermined or undefined. Whereas the secant, if I take the reciprocal of 1 over 1, I still have 1 over 1, so this would be 1. All right, then the tangent is sine over cosine. I know that the sine is 0 and the cosine is 1. So that means that the tangent is 0 over 1, or just 0. And the cotangent would be cosine over sine, because tangent and cotangent are reciprocals of each other. So if this is 0 over 1, then this is 1 over 0, which means that the cotangent is going to be undefined as well. Okay, number 2. This time I'm given sine is negative 1/2, and the secant is 2 square root of 3 over 3. All right, well, flipping this upside down, the reciprocal would be negative 2 over 1. So the cosecant of theta, this is going to be negative 2. Going from the secant to the cosine, so the reciprocal of the secant, this would be 3 over 2 square root of 3. However, I don't like having that square root of 3 in the denominator, so I'm going to rationalize the denominator. That means multiply the top and the bottom, the square root of 3. So this is going to be 3 square root of 3 over 2 times 3 is 6. And then 3/6, this can reduce to 1/2, so this will be the square root of 3 over 2. Okay, then the tangent and cotangent are left. The tangent, let's do that first. Tangent is sine over cosine. So in this case, it'll be negative 1/2 all over square root of 3 over 2. Okay, I've got a rule here. If the denominator here is 2 and the denominator here is 2, I can divide these out. And I'll be left with -1 over square root of 3. Then, of course, let's rationalize the denominator. So I'm going to multiply the top by square root of 3, multiply the bottom by square root of 3. So I've got negative square root of 3 over square root of 3 times square root of 3 is going to be 3. Okay, so the tangent is negative square root of 3 over 3. The cotangent is the reciprocal of the tangent. So once I've found that the tangent is negative square root of 3 over 3, then the cotangent is going to be negative 3 over the square root of 3. And when we rationalize this, let's find out what happens. This will give me negative 3 square root of 3 over 3. Divide out these 3's here, and I'm left with negative square root of 3. Okay, so a lot of what we did right here involved the reciprocal identities, as well as for tangent and cotangent, the quotient identities. So you'll want to be really familiar with these identities right here. Moving on. Simplify the trigonometric expression. Okay, so oftentimes when I'm working on problems where I want to simplify trig functions, trig expressions, I want to change everything to sines and cosines if they're not already there. So when I see number 3, sine squared of x, perfect, that's already in sine, but cotangent is not. Cotangent is cosine over sine. So that means that cotangent squared would be cosine squared over sine squared. So this gives me sine squared stays the same. I could write that as sine squared of x over 1 if I'd like, times, I just found that cotangent squared is the same as cosine squared of x over sine squared of x. What happens here is the sine squared on the top will divide out with the sine squared on the bottom, leaving cosine squared of x over 1, or just cosine squared of x. All right, next one. Secant times 1 minus sine squared of x. So whenever I see a 1 plus or minus a trig function, or whenever I see squared, I should say, or whenever I see two trig functions that are squared being added or subtracted to each other, I want to see if any of my Pythagorean identities could apply here. I bring over my list of identities and I find a 1 and a sine squared. So let's go down here, and I've got sine squared plus cosine squared equals 1. Well, I want to match this Pythagorean identity to what it's written here. This says 1 minus sine squared of x. So if I subtract a sine squared from both sides here, I will get 1 minus sine squared on the right side. Okay, on the left side, that'll go away, leaving just cosine squared of x, or cosine squared of theta. So 1 minus sine squared of x should be the same as cosine squared of x. So I can replace this part with cosine squared of x. All right, then the secant, if I look at my reciprocal identities, secant is the same as 1 over cosine. I could also think of this cosine squared as cosine times cosine. So that would be 1 over cosine of x times cosine of x times cosine of x over 1. And that'll make it a little bit easier to see that this cosine of x in the denominator will divide out with one of these. Leaving just 1 times cosine is cosine over 1, or just cosine of x. All right, number 5. Sine of x times the quantity cosecant of x minus sine of x. Okay, so this will be to write everything out in sines and cosines. I know that I've got a cosecant here. That cosecant is going to be the reciprocal of sine, so I can write this as 1 over sine. So I'll have sine of x over 1. I'm going to write these as fractions. Times cosecant, I said, is going to be 1 over sine of x. Minus sine of x over 1. Okay, let's distribute. So this sine of x over 1 will get multiplied there and there. So this will give me sine of x over sine of x minus sine squared of x. But of course, sine of x over sine of x, this is the same as saying 1. So I could say that this is 1 minus sine squared of x. We'll bring back my Pythagorean identities. 1 minus sine squared of x, similar to how I did this before, I can subtract a sine squared of x from both sides and get 1 minus sine squared of x is the same as cosine squared of x. So this simplifies to cosine squared of x. Okay, last one on the front page here, number 6. I've got sine of x plus 1 times sine of x minus 1. So let's treat this like anything else here. I would do a box. So sine of x plus 1, sine of x minus 1. This will be sine squared of x. This will be negative sine of x. This will be positive sine of x. And then negative 1. When I go to combine like terms, I've got a negative sine of x and a positive sine of x. Those will divide out. And what I'm left with is sine squared of x minus 1. Okay, sine squared of x minus 1. Again, I know that sine squared plus cosine squared equals 1. So sine squared of x plus cosine squared of x equals 1. If I subtract 1 from both sides, that'll be sine squared of x plus cosine squared of x minus 1 equals 0. And then if I subtract cosine squared of x from both sides, I would have sine squared of x minus 1 equals negative cosine squared of x. And now this sine squared of x minus 1 matches this here. So this would simplify to negative cosine squared of x. All right, moving on to the second page. Let's rewrite the following trig expression so that it is not in fractional form. So sine squared of x plus cosine squared of x over sine of x. Well, Pythagorean identity, sine squared plus cosine squared is 1. So this is 1 over sine of x. And then looking at my reciprocal identities, 1 over sine is cosecant. And that gets rid of the fraction. So this is cosecant of x. All right, this one, cosine over 1 minus sine squared of x. So 1 minus cosine squared of x, if I use my Pythagorean identity and I subtract cosine squared from both sides, I would find that this is sine squared. So this will be cosine of x over sine squared of x, which is really the same as saying cosine of x over sine of x times 1 over another sine of x. Cosine over sine is the same as cotangent, and then 1 over sine is the same as cosecant. So this would be cotangent of x times cosecant of x. For 9 and 10, we are verifying that the following are identities. Typically what I do is I pick one side, and more often than not, I would pick the side that looks more complicated. And I try to simplify that or work with that to try and match that to whatever the other side says. So for number 9, I see that I've got sine squared over tangent squared. I'm going to see if I can rework this so that it is the same as cosine squared of x. So let's begin by saying I've got a fraction here, and I know that tangent is sine over cosine, so tangent squared is sine squared over cosine squared. So this will be sine squared of x over 1 all over sine squared of x over cosine squared of x. Let's multiply the top and the bottom by the reciprocal of this bottom fraction. So I'm going to multiply by cosine squared of x over sine squared of x. All right, everything down here divides out. Even this sine squared here and here. So what I'm left with is cosine squared of x over 1, or just cosine squared of x. So yes, because I was able to rework one side to match the other side, this verifies that this is an identity. This one's a little bit tricky. I've got 3 plus sine squared of x equals 4 minus cosine squared of x. Off to the side, remember that one of my Pythagorean identities says sine squared plus cosine squared equals 1. Well, that also means if I subtract cosine squared from both sides, sine squared is the same as 1 minus cosine squared. So what I can do is say 3 plus sine squared. This is the same as saying 3 plus 1 minus cosine squared, which 3 plus 1 is 4, and I still have minus cosine squared of x. And then now that matches the other side. So this shows that yes, this is an identity. All right, the last one's solve the following equations, giving an answer for all possible solutions. All right, let's start by trying to get cosecant of x by itself. So I'm going to add 2 to both sides. So this will be square root of 3 times cosecant of x equals 2. Let's divide both sides by square root of 3. So I'll have cosecant of x is equal to 2 over the square root of 3. Now cosecant is the reciprocal of sine. So this is, if I flip this upside down, this will give me sine of x. And if I flip this upside down, this will be square root of 3 over 2. So I want to know, when is sine of x the square root of 3 over 2? I bring over my unit circle. Oops, here we go. And square root of 3 over 2 occurs here at pi over 3. Okay, and then square root of 3 over 2 for sine again appears at 2 pi over 3. But this is for all possible answers. So every time I go around the circle and I hit this spot, this is a solution. Every time I go around the circle and I hit this spot, this is a solution. Well, that means that every 2 pi, I get back to pi over 3, and every 2 pi from this point, I get back to 2 pi over 3. To indicate that this could be for any amount of 2 pi's, the first 2 pi, the second 2 pi, the third 2 pi, I'm going to write my solution as x equals pi over 3, but then plus 2n pi, and then x equals 2 pi over 3 plus 2n pi. All right, number 12. Solve for cotangent. So let's subtract 1 from both sides. So the cotangent of x is equal to -1. Reciprocal of cotangent is tangent. So tangent of x equals reciprocal of -1 is, well, still -1. And then again, I bring over my unit circle. And I say, when is the tangent -1? So that is 3 pi over 4 and 7 pi over 4. However, I notice that these are exactly half a circle away. So instead of saying 3 pi over 4 plus 2n pi, and then 7 pi over 4 plus 2n pi, I can just say half of that. Pick one of these, 3 pi over 4 plus n pi will get me to 7 pi over 4. So x equals 3 pi over 4 plus n pi. All right, the last one, cosine of x times cosine of x minus 1 equals 0. These two are multiplied together and equals 0. So I'm going to say, what if just cosine of x equals 0? And what if cosine of x minus 1 equals 0? Add 1 to both sides here. Cosine of x equals 1. Okay, cosine of x equals 0. That's going to occur at pi over 2. And that's going to occur at 3 pi over 2. So since they're halfway across again, I'm going to say just one of them, pi over 2, plus n pi. And then for cosine of x equals 1, that occurs at 0. And then every 2n pi. So I'll say x equals pi over 2 plus n pi, and then x equals 2n pi. So 0 plus 2n pi, or just 2n pi. All right, that's it. Hopefully this helps you out, and study up for the actual test.